All right. Well, it's my pleasure to introduce our very own Sophie Libkind. And she's going to talk about hosting workshops and what happened at a recent workshop.
Indeed.
Thank you.
Yeah, thank you, Chris. Recently we had the ACT2Infer workshop hosted here at the Topos Institute at the end of September. And today I want to give actually two talks. The first talk, I want to share look, hosting workshops is like a tool we have at Topos that can do really cool stuff, according to me. And I want to share with you a little bit about how I think about workshops, and maybe you will be inspired to be like, oh, maybe we could host a workshop about such and such. And then the second, so then we'll yay, all done with that talk. And then the second talk is about sort of my mathematical takeaways from this workshop. All right, are you guys ready? Sweet. OK, so hosting a workshop. First question, what is a workshop? It's a tool. What does it do? So this is sort of my first draft at what I think workshops are. So I think workshops are for building together. I think conferences are for sort of more sharing information. And workshops are really for getting your hands dirty with this stuff. So I think of them as a tool for creating different type of stuff. So for example, knowledge, that's like a research workshop, or decisions, or relationships. So different things you can sort of build together. And so since we're sort of getting our hands dirty and building, at the end of each workshop, one of the things that we've done with our last couple is make sure that we have artifacts, what is the thing that we built? At the Poly workshop that we hosted last February, we had each participant write for 90 minutes, just like a blog post or a little overleaf, and then post it. So then we have the posted work about sort of what was the research outputs of that workshop. At the ACT2Infer workshop, which we just had, we had each participant record a 5-minute video that sort of shared their main takeaways from that workshop. OK, so if workshops are for building together, where do we start? So to me, a workshop starts with a bold and sharp purpose. And this bold and sharp purpose is something I got from a book called The Art of Gathering, which I think is incredible. Highly recommend if you're hosting anything. And so what was the bold and sharp purpose of this recent ACT2Infer workshop? So to me, it was to begin the process of articulating and clarifying the underlying principles of active inference, which is sort of a research topic about how is learning and knowledge created and used in the world, via the formalism of category theory, which is, at Topos, what's really in our wheelhouse. All right, so if that's our bold and sharp purpose, how are we going to do it? So I think it also starts with a well-crafted invitation. So it's very good for me to have the bold and sharp purpose, but I also need to make sure that the people I'm inviting know what that is. I think David and I probably spent at least an hour sort of writing a couple paragraphs that really shared with our guests or our potential guests what we're trying to hope to do at this workshop so that they can decide, yes, this is for me, or no, it's not. So we have our invitation. We invite our guests. Here are our guests. We had, because our purpose was to sort of combine active inference with category theory, we had a mix of applied category theorists, people who really knew the nuts and bolts of all sorts of different types of mathematics, as well as some experts in active inference, people from places like the from STEM AI and the Active Inference, oh my gosh, I'm forgetting its name, Institute, the Active Inference Institute. It was a really great mix of people with lots of different backgrounds and sort of eager for that cross-pollination between the two fields. All right, so we have our bold and sharp purpose. We wrote our invitation. We've got our guests. Now we need to do stuff. So I want to tell you about the schedule. For us, David and I crafted the first draft of the schedule in July. The workshop was in September. We sort of walked through each day thinking how would it feel? How does this day feel? Does it have enough small group stuff and big group stuff? And are people getting bored here? So we had a lot of what does it feel like to go through the day? Then of course it actually comes, and we don't throw the schedule totally out the window, but every single day we were making changes to sort of respond to the needs of the group. So what you're seeing here is the end result of the schedule. The first draft looks actually quite a lot different. And it did have a mix of a couple of traditional talks with a person standing up here, saying some things to an audience, breakouts where we have small groups doing different stuff, lightning talks, which you may know from the Berkeley Seminar, and also an activity called questing, which I'll talk about. So I guess I want to highlight some of the bits. So the first bit I want to highlight is opening session. That's the first thing you welcome your participants and your guests into. And I think it's actually like, I don't know, I have a recommendation, which is to like spend time, just the way you spend time to craft your invitation, spend time crafting your opening session. It's a great time to like tell people like what they're there for, to like get them in the mindset to do the thing that you want to do, and also how you want to do it. So sometimes during open session, I'll give like tips about, different ways of how you might want to interact or think about using your time at this workshop. So just like opening session, I think the end is also pretty interesting. So we spent, it was only a 2.5-day conference, and we spent most of the last half day working on these artifacts. Because, we said, the artifact is, in this case, the best 5-minute talk that you can give us. Like, we spent 2.5 days getting to know each other. Now, like, it might be the same thing you wanted to tell us at the beginning, but now that you know us, like, you can sort of address what you want to say to us, or the nugget you want to leave sort of the group with. And I do really like having, I think, there's sort of like a, ooh, but like we just want to keep having cool conversations. But David describes this as like a ratchet, like you make some progress and then you want to lock it in because we're going to go away, we're going to disperse, we can meet again. But it's nice to have that reminder of like what we did. All right, the next two things I want to talk about in the schedule are things that the participants reported as being like their favorite activities. So one of their favorite activities was lightning talks, which again you might know from the Berkeley Seminar. But I think in the context of a workshop, it actually served a slightly more pointed goal. So I thought of it, over here you can see lightning talks has 3 purposes. The first is to actualize potential, which is a David Spivak phrase, where you're like, oh man, there's like a lightning rod and you're like the charge in the sky and you're like, oh, if I can just make contact, we can like make stuff happen. Another one is pressure release. Like sometimes I'm like, oh, I just really, really need the group to hear this. And it's just a spot to be like, hey group, let me tell you about the thing you're all missing or whatever. And the third one is like an advertisement. Like sometimes you're like, oh, I'd love to lead a breakout about XYZ, but I need people to know what XYZ is first, and so you have a moment to give an advertisement. Another thing is, although at the Berkeley Seminar we did lightning talks, in the workshop, I think because it was a small group that had a lot of flow, we were able to do lightning jazz, where the talks themselves sort of bounced off each other. Sometimes people would start a new thread, but you got sort of almost like a conversation happening through the lightning jazz. The next sort of type of activity that had high reviews was questing. And so questing is one of my favorite things because I think it makes communication both efficient and wholesome, which is hard to do. Like it's hard to have something that like, is sort of quick, but also really addresses like who the people in the conversation are. So with questing, you have it's a bunch of very short conversations between 2 people. One person is playing the role of the protagonist who has a quest. For example, my quest was I wanted to get a toy model of active inference. And then the other person is playing the role of sidekick. So the sidekick is just, or the squire. So the sidekick is just like, hey, protagonist, like, what do you need? And he's like, oh man, can you explain this to me? And then they start, and I'm like, oh, actually, I get that. Can we jump over here and do this thing? And so like when you're in the role of the protagonist, you're driving the conversation, and you're like, you really get that sort of that efficiency, but while you're sort of attuned to like who the protagonist is and who the sidekick is, because it's such a small conversation. And so we did like 5 rounds of this, where we each got to meet a bunch of people in a short amount of time. Yeah. Okay, so we had some bold and sharp purpose. How did we do? I think we did pretty good. So from my own sort of sense of it, as well as from reading feedback, I think we left with a sense of enthusiasm and connection between the people in the group. And then also with some object level progress. In particular, I'll share with you my object level progress in my next talk, happening very soon. One remaining question that I have from this workshop, sort of in the back of my mind as we were hosting this workshop, was like, in general, what is it like to have this cross-pollination between applied category theory and a domain field, especially with people who themselves aren't maybe category theory experts? And one of the things that I felt like I didn't know how to do well in the workshop, which I want to learn how to do well, is show the value proposition of category theory. I think it's sort of easy for people to misconstrue what category theory might do for them, and that's something I want to get better at showing in sort of a short amount of time in a workshop setting. Okay, so, last part, Molly is absolutely incredible. Round of applause for Molly. When we ran the polynomial functors workshop in February, it was like not only were David and I running the program, but we were also doing most of the operations work, like making sure the coffee was out and like that the room was set up right. And Molly was just so amazing at taking that bit and a lot of the like sort of also like managing sort of the high level logistics. Back in January or in July, you know, we crafted this like what we sort of want in terms of like food and logistics, and we worked really well together in making that all happen. So thank you, Molly.
May I make a comment?
Yeah, in fact, that's all. And I would love to get some like questions and hear what you guys are interested in about workshops. So let's do, sorry, yeah,
Both
go ahead.
Before and afterwards.
Yeah.
I hate to mention funding, but sometimes having a special speaker will get people to come, but you may have to pay for the speaker to be part of it. So you need to think of that in advance.
Yeah, I think.
Second thing is YouTube videos are very nice, but I think it's better to save slides because often slides have bibliography on them. It makes it easier to follow up things that came up that you can't read your notes, but you can read the slides.
Thanks. We'll keep that in mind for future artifacts. Shall we?
Can you speak, talk a little bit about how you choose people or choose guests? Like, should we have a lot of people? Should we have very few people? What about the backgrounds of people? Like, what are some of the thoughts that you have when you were designing this?
Yeah. Here's the way I wish we had done it. So we started out with sort of like some obvious people from like the applied category theory side, as well as sort of the people who brought the workshop to us were like the active inference. Some people from active inference were the ones who sort of brought the idea of the workshop to us. They also had sort of a group of people. And so we started just by sort of like putting those two together and being like, all right. And then, yeah, sorry. And then so you were asking about like, how do you choose which people? How do you, yeah.
Let's say we start with group size. If you have a big group, I guess small groups have more intimate like conversations, and the big groups are also good for disseminating information to a lot of
people. I think the real answer is that I don't have a good answer for this. I think this was actually a place that we could have like used improvement on in this workshop. But that in general, I think it should come from that bold and sharp purpose. Like, if your bold and sharp purpose is to do a very specific thing, then it should be like people who are on board, maybe a small group of people who are on board with that specific thing. If it's more this like community building, as this one was, I think it makes more sense to maybe have like more people around. And so I think it really, I would like bounce off that purpose as I was thinking about those questions. Yeah.
How big is big? I would think that a dozen might be a reasonable size, but that might even be too large.
So this was 10 people. I think it was a nice size. I think we could have taken a couple more. Our polynomial functor workshop back in February was 16 to 18, and that felt sort of like the biggest we could have in this particular space. And also a nice size for that workshop. We had a lot of different small working groups instead of sort of more big group stuff. Maxine?
I would just follow up with sort of the question that you had remaining after the thing,
yeah.
Like the value proposition for category theory in different spaces for that. That I think that is something that is like a shared sort of like object that would be incredibly like helpful to have like a documentation of just like something that, because I think in addition for like workshop settings, like in other places, it's something that I've run into as being like a thing that would be really awesome. So I share that and hope that if that happens, that there's like a document that can be pointed to or something.
Yeah, it would be great.
It would be a very awesome thing for other things.
Yeah, a replicable way of showing the value proposition of category theory would be incredible. Yeah. Nice. Beth?
I just wanted to state, I know that this workshop was shorter, so I can see why you would do the artifact the way that you did. Wondering if from the artifacts from the polynomial workshop, if there was work that was pulled out of that based on the fact that people were able to like put together more time.
Yeah, I think a lot of, that's actually something I would love to follow up with our workshop participants in general, is like in 6 months being like, hey, anything going on that started at the polynomial functors workshop? I don't know particularly from the polynomial functor workshop from the ACT2Infer workshop, there is interest in like writing a paper based on the work that I will present in the moment. Yeah.
Is there publicly accessible output from this workshop? I'm looking at the web page.
Yeah. It is not yet publicly available, but some of the videos will be shortly publicly available as soon as I do that. Cool. Any other questions? All right, we're on to talk number 2. I don't know, is that weird? Oh well. It's hard to be the host and the, all right, hello, welcome to another talk. Today, I'm really excited to tell you about something that I learned about at the ACT2Infer workshop, or something that, like my object level progress from the ACT2Infer workshop, which is I now have a polynomial account of active inference, which I've been looking for months, if you've been around. Last spring, I think I even gave a talk in the Berkeley Seminar about a polynomial account of Bayesian update, which is about like, how do you sort of know what's going on based on your observations and sort of a model of your world. And then the next question is like, all right, so then how do you act? How do you decide what to do? And that's sort of like something that active inference talks about. So let me tell you a little bit about my story. So as I said, we did this thing called questing, and my quest was I wanted a toy model of active inference. So my first sidekick was Daphne, and I was like, hey, Daphne, can you just like write down on a whiteboard the most basic model of active inference? And she was like, sure. And so we got this thing. There's like, you know, this matrix A and this matrix B, and they all interact and do some incredible stuff. And then my second questing sidekick was Daniel, who was just like always happy to talk about active inference. It's pretty great. And I was like, all right, I have this model. Now I want to make the smallest possible example that we can together, because I am a person who likes to work from examples, and I feel like that often helps me understand what's going on. So we had this model about like the room is either, you know, hot or like 70 degrees or 85 degrees, and then I can feel either hot or cold, and then I can like adjust my thermostat. I can turn the heat on or cool it or leave it be. And from there, one of the cool things that I thought was in his picture, we had these sort of like trees going on, and I was like, hey, you know where I've seen trees before? Polynomial functors. And so even in that conversation, I was like, I have the sense that this can just be turned into a poly story. And in fact, that's true, which I figured out the next day. Yeah, Xiaowei.
Is the diagram on the right related to the diagram on the left?
So this is like the model type, and this is like a particular instance. Yeah. Although they, I agree, look very different. Sorry. Yeah. And so as this was also sort of my artifact the next day, and as I tried to present it to the group, I wanted to think about like, you know, this is certainly a way of showing off active inference. And the reason I'm interested in like turning this into a polynomial functor account is because poly is an ergonomic and portable, and I think of it like a programming language. It's like you know, just the way you can write down this model in Python, I can write it down in Poly. And of course, it doesn't run on a computer. It runs on, at the moment, people. But like, it really runs. Like, I can show David this story, and he can understand it in like 15 minutes. Versus like, if we were trying to go through this with a Python program, it would take us a lot longer. You know, of course, we have a lot of existing like, you know, domain knowledge about Poly and also a relationship. But I think once you have that, it becomes very portable. And then for me, it's also ergonomic. Like, to me, these pictures make sense when I'm writing them on the whiteboard, and then I go away and I'm like, oh no, what does that arrow mean? And like, Poly doesn't have that problem for me. All right, so let's do the account. Let's first start, actually, though, with a polynomial account of Bayesian update, which is, again, I think I gave a talk on this last spring. So here's the way it works. We start with two sets, a set of hypotheses about like what is the actual state of the room. Either it's 70 degrees or it's 85 degrees. And some data, like what might I observe? I might observe H being too hot or C being too cold. Yeah?
This is pretty small. Is this maybe unsolvable
well,
in a reasonable amount of?
Okay. I won't show you why it's so small, but you'll see why it's so small in the future. I think for now, I could zoom in a bit and just do some scrolling. Yeah, okay, sorry. All right, we'll do some scrolling. All right, so as I was saying, we have a set of hypotheses and a set of data, what I might observe. And then we also have what's called a likelihood. So for each hypothesis, it's a lottery, or you can also think of this as a random variable whose outcome is some data. So at 70 degrees, I have a 50-50%, like 50% I feel too hot and 50% I feel too cold. Like that's how 70 degrees is for me. But if it's 85 degrees, I almost always feel too hot, 90% of the time, and only 10% of the time I feel cold. That's what a likelihood is. Questions so far?
Is that how you draw a lottery?
I used to draw them like this, but because I'm going to have, in the future, lotteries with like 18 things, the square brackets started making more sense. Okay. Yeah, and this is how I draw a lottery. Okay, what's next? Woo! Okay. All right, okay. All right, Kevin. I don't know. I don't know about this. What?
Not even the farthest back.
There's seats up front, guys. Okay. So, sorry. All right. I've learned something today. What? Opera glasses, exactly. That's what we're missing at the Berkeley Seminar. Okay, so here, now we're going to do our polynomial conurbation update, where we're going to start with a prior. So this is like, I'm really just like 50-50 unsure if it's 70 degrees or 85 degrees in the room. I just have no idea. It's a random coin toss. And at the end, what I want is something that says, given some data, do I get to update my prior and be like, oh, actually, I think it's probably 70 degrees, given that I feel this way. Or, oh, no, probably I feel this other way, given some other data. And we're going to get there by doing these very small steps in poly. Like, poly's like, oh, I had a word for this. It's like, in Python, they're like primitive functions, just like things you can just type in and Python really knows about. These are all like primitive functions in poly, just like really the basic stuff. Okay, so the first thing we're going to do is we're just going to duplicate the hypothesis, because we're going to need to do two things with it. One, we want to remember it, and then we're going to do something with that first copy. Next, we're going to apply the likelihood. So in place of this hypothesis, I'm going to pop in the likelihood. And so what this becomes is this is sort of a random variable whose outcome is, do I feel hot or cold? And what was my expectation about what the hypothesis or what the state of the room was that gave me that? Too big, too small? All right, I'll try. Oh, okay, here's what I'm going to do. Here's what I'm going to do. Everyone close your eyes. Okay, now we'll zoom in. Okay. Okay, okay. So we just, what? What? Oh, you can open your eyes now? Sorry, Chris. All right, so we applied the likelihood. We replaced this guess about what the state was with instead the data I would receive if it was that state. Now we're going to add in sort of what it would mean to get the data. So we're keeping this bit the same, and I'm just saying here I have a branch for if I observe feeling hot and a branch for if I observe feeling cold. If I observe feeling hot, I remember that I felt hot, and then I add in the random variable about like, did I feel hot or cold and what was the state of the room. The next thing I'm going to do is I'm going to compare the data. I'm going to compare the like my observation, which is here, with sort of like what I expect to feel in those different worlds. And so here, like, I experienced feeling hot, and also I sort of like expected to feel hot, so that's like, great, continue, and in that world it was 70 degrees. Here I compare, I observed hot, but I was sort of expecting cold, and so I put a little dot, that's my like +1 here. And I keep doing that until I get sort of these 4 different matching outcomes. All right, take a picture of that in your mind. And now we'll scroll down here. What we're now going to do, I'll just tell you, is combine the lotteries. So like here I sort of have 2 random variables, and I'm just going to combine them. So this branch will become like 0.25. This branch will become 0.25. This branch will become 0.45. This branch will become 0.005. There we go. So that's exactly what I said was going to happen. Just compose the lotteries. And then our last step was sort of like, in some ways it felt like the key ingredient to all this Bayesian update stuff was this process of what we used to call conditioning, but which I really think is, I'd like to call renormalizing. Because we're saying, you know, get rid of the ones where we didn't have a match, and then renormalize the remaining distribution. And so, and this is what we end up with. So we started with like 50-50, it was 70 degrees or 85 degrees. But if I experience being cold, that was super unlikely if it was 85 degrees. So now I have a much higher probability that it's actually just 70 degrees. Versus if I felt hot, like, it doesn't give me as much information. Because at 70 degrees, I'm still pretty likely to feel hot, even if it's 70 degrees, although I'm very likely to feel hot if it's 85 degrees. OK, so that, yes?
So what happened
Show
on
you.
the slide is you did a Bayesian update. You said what the posterior is going to be based on observation. So far, we haven't done anything that's unique to like activity.
Correct. This was just recalling our usual belief updating Bayesian update story. So just given, and this is just sort of about, it's like I don't get to, my hands are tied behind my back. I just have some belief about how the world, some sort of model of how the world works here. And then I observe data, and I try to figure out what state the world is in. Dennis.
Are the arrows all morphisms of polynomial functions?
Exactly. And they're all, in fact, they're like these like really primitive ones. Nothing sneaky going on.
Would it be fair to say you're generating explanations?
Ooh, generating explanations.
Yeah, and you've summarized everything in a much more understandable way. So
I think I don't quite get it. Like this is an explanation at the end, or this whole story?
you knew that something was going to happen with your feelings,
Uh-huh.
and the question was why. And so when you went through all of this, you boiled it down to that.
Yeah.
Simple,
Yeah, given that I sort of expected, then this is what I guessed about the world so far, and I felt this way. What's a good explanation for why that happened? Yeah. Maxine? Oh no, that was just, sorry. All right, cool. All right, are you ready for active inference? Great, let's do it. Okay, so let's zoom in. We're going to start with pretty similar stuff. We still have our hypotheses, we have data, but now we have actions, because now my hands are not tied behind my back. In this world, I can do three possible things. I can heat the room, I can keep the room the same, which is called stay, and I can cool down. It's actually not cool down the room. I can like press a button that says like heat, I can press a button that says stay, and I can press a button that says cool. And later I'm going to tell you like what those things do.
Your actions are named Big I.
Yeah, this is what the active inference people use, so I copied them, although, yeah, probably it should be A for me because they also don't call it H and D, so, but yeah. All right, so we still have our likelihood, same as before. You know, if it's 70 degrees, 50-50, I'm hot and cold, 85, probably I feel hot. Then we have a transition function that sort of tells us what the actions mean. So it says, given the state of the world, a hypothesis, and an action, give me a distribution on next states. And so the way I've set up my model is like the heater always works. So if it was 70 degrees, it'll, with 100% probability, become 85 degrees. If it was 85 degrees, it'll 100% stay 85. Keeping the room the same, also 100% of the time works. Cooling doesn't quite always work. So if I try to cool the room and the room is already cold, that'll work. But if I cool the room and it was 85 degrees, then like a quarter of the time it stays 85 degrees because my cooler is sort of faulty. But 75% of the time it does work and it goes down to 70 degrees. Does that make sense? Cool. All right, and the last thing I have is I have a preference. So I have just one lottery over data, which is sort of like how I want to feel. Like I prefer to 80% of the time feel hot and 20% of the time feel cool. I think you can also think about this as I think if you're doing like all the fancy active inference stuff, you can also think about this as the expectation. Like I expect to 80% of the time feel hot. I want the world to be such that I expect 80% of the time to be hot and expect 20% of the time to feel cool. Okay, so that's what we're given. And now what is a model of active inference supposed to get us from that? We're supposed to get one, belief updating. this is exactly the same as before. So given a prior, i.e. like what I think the state of the world is, given a piece of data, I didn't talk about this before, but either that data was impossible and I err, or it was possible and I get an updated, like what I think the state of the world is. So that's called belief updating. That's going to be the same story we just told from Bayesian update. And then what's the second thing we want? Sorry, guys. Oh, hang on. All right, the second thing we want is policy updating. So in policy updating, we start with what I sort of, my prior over the current state of the world. And we call this a habit. So it's a prior over actions. Like, I don't know, most of the time I just leave the room the same, but sometimes I make it hot or cold. And then given a piece of data, again, either that data was impossible, or I get an updated distribution on actions. So like, given the state of the world, oh, actually, maybe I should want to heat the room a little bit more, something like that. So again, like belief updating, we already did. So the rest of the talk is just showing you the story of policy updating in the same way that we showed the story of belief updating on the last slide. Yeah.
How could belief updating fail again, like the error?
The error. So you could imagine, suppose, let's see, I'm going to go to the, OK, so, whoa, that's not what I wanted. OK, suppose the likelihood here was like, if it's 85 degrees, then actually I always 100% of the time feel hot. And suppose I started with a prior that's like, it's definitely 85 degrees. And then suppose I received the data, I'm cold. And I'm like, that's impossible. That's when you err. Yeah, and it's called Bayesian hell is another word for it. And this is, OK, like just to, why I like polynomial functors, I think when you read this in a Python program, it's very hidden. It's like not that, like, hello, this is what's going on. In the polynomial functor story, like, we just had to put in this y plus 1, otherwise it wouldn't work. It like makes it very visible, that part of the story.
Yeah, it's hidden in the division by 0 error.
Exactly, exactly. Yeah, it's hidden in the division by 0 error in Python. And here it's like, hello, here I am. OK, I think if we're going to do some zooming, then you all have to close your eyes. And you can open them. Oh, no. OK, here we go. OK, policy updating. So we're going to start with two things. Again, a prior on hypotheses. So again, I'm starting with like, I don't know, random coin flip if it's 70 or 85 degrees. And also a habit. So here my habit is 70% of the time I keep the room the same. 10% of the time I heat it. 20% of the time I cool it. That's just like my habit about what I do. OK, so the first thing we're going to do is just take this prior on hypotheses and, ooh, that's fun, and do, like, apply my Bayesian update to it. Oh, no, that was terrible. OK, apply belief updating. OK, here we are. So this is exactly what we got when this is exactly the end result of doing Bayesian update. Then what are we going to do? Next, we're going to use, oh my God, sorry about the size. Next, so we applied belief updating. Now here we have sort of, for observing hot and observing cold, a random variable that tells you what state of the world I think the world is actually in. Now I'm going to combine these via, again, sort of one of these primitive polynomial functions, primitive functions between polynomials called duodality. And I'm also going to duplicate the action. And so let's walk through this. It's like, if I observe hot, then I have, according to this, 36% it's 70 degrees, and 64% it's 85 degrees. So that's where this 36 and 64 are coming from. But then before I do the 70 and 85, I'm going to plop in this lottery here. And then I'm going to remember what I had. So over here, if I did, I saw hot, 36% at 70 degrees, and also 10% I heat the room. And then I'm just going to duplicate the heating the room. And so what the result is it's like for each observation, either hot or cold, I have basically a random variable whose outcome is what is my like updated hypothesis based on that observation, and what is my habit? What action am I going to take based on my habit? All right, how we doing? Dennis, yeah. Duoidality, yeah.
Was that like an interaction between tensor and
Trie?
Okay.
Exactly. Yeah, it's an interaction between tensor and trie.
Does it do something like A trie B tensor C trie D, and then you interchange in order?
It does A, certainly. Yeah. Well, let's do P trie Q tensor R trie S to P tensor R trie Q tensor S. And here, sorry? So this times is a tensor between these sets H and pi. Nice. Ready for the next one? Okay. Let's move over to see what I said. Okay, so we're going to now look. We've got, sorry, we need a bigger screen. That's the problem. And opera glasses. Okay, so we have, right, so here we had, for each observation, a random variable about the current state and the action I'm going to take based on my habit. Now I'm going to apply the transition function. So given that like it was 70 degrees, I think it's 70 degrees, and I decided to heat the room, I can update and get like my sort of next state, 85 degrees. You know, if it was, it was 70 degrees and I heat it, then I get 85 degrees. So here I'm replacing this thing with a lottery, or a random variable whose outcome is the sort of next state of the room. Let's look at one that's, the cooler is faulty. So if I follow this path, I'm like, I felt hot, 64%, it's 85 degrees, and also I decided to cool the room. So this one is actually getting turned into this like two-branch thing where 25% of the time, if it was 85 and I cool it, it remains 85. 75% of the time, if it's 85 and cool, it'll actually cool the room. And then on top, I'm just remembering what action I took. So again, what is this? It's for each observation, either hot or cold, a random variable, that's basically all the stuff in purple, whose outcome is the updated state, the next state of the world. And remember what action got you there. All right. Questions about this one? We have lots of time, so feel free to go slow. I'm feeling free to go slow.
Tell me what active inference is. Like it's something of the form. It takes a hypothesis and a habit, or primary hypothesis and a habit, and returns that kind of data.
It's going to we're eventually heading here. So given a prior and a habit, then given a piece of data, either that data was illegal or I get an updated habit. So that's what, and then this is like the habit I'll like draw from to actually take my action.
Is it a simplification, or how it really works that your habit doesn't depend on your data, right? It seems like I would say 20% of the time I turn the temperature down if I'm cold, but probably if I'm hot, I turn the temperature down more often.
It does, because I'm going to get some data before I decide my updated habit. Is that not what you meant?
That's updating the habit, but the habit itself is somehow marginalized over all observations, right? I say 20. You said the habit is 70% of the time I do nothing, 10% of the time.
Oh, yeah, I see what you're saying. That is a great question that I would love to ask an active inference expert.
So maybe it could be.
Yeah. Did that answer your question, Brendan?
I think so. Can I ask a question about belief too?
Sure.
Is there a distinction that you see between like 80% of the time it's hot and 75 degrees and 20% of the time it's like state of the world? Okay, let's go with the temperatures. 80% of the time it's like 70 degrees and 20% of the time it's 85 degrees. Or I believe with like 80% confidence that it's like 70 degrees. Are you distinguishing between those two uses of
So your question was, I could either interpret like a prior here as I don't know the state of the world, either 80% it's this and 20% it's that, or on average like 80% it's this and 20% of this. I think when I think about a prior, I think of the first one, although I don't know in general.
So sometimes you've been saying the other one as well. Well, I've been hearing the other one, where you say like, 80%, 20%, 80% of the time it's this, 20% of the time it's that.
I've been saying
Are
that.
they compatible in this situation?
My guess is they're compatible. Like, I feel like that's one of the cool things about the active inference story is somehow all the different ways of thinking are compatible, and that's how you get these cool statements, although maybe dangerous statements or something. Where I've been saying the like 25-75 is like this one here. Like if it's 85 degrees and I cool the room, then I'm like 25% of the time it remains 85 degrees, 75% of the time it becomes 70 degrees. But I could say that like if it's 85 and I press the cool button, now I have this uncertainty. With 25%, like I have this uncertainty about if it's 85 degrees or 70 degrees in the room. And that feels quite matchy to me. Yeah.
Multiply out the probabilities for that same sort of thing.
Yeah.
And they're all about beliefs.
Maxine?
Can I offer just like a paraphrase of what my impression of like the setup for this?
Yeah.
So it feels like sort of with belief updating, there's this like dynamics on beliefs. Like you have a lot Y, and then you have like a thing where I can input data, or sorry, lot H, like a lottery of something about the world, and I can put in data, and then get an updated one, and I can like iterate that because I can glue those together. Like there's like a way in which, because like the magic of like the operations that you're doing for that. And so in this setup, there's like a special kind of dynamics on the belief updating, which is that, well, in particular, if I have like a transition function that says like, if I do a thing, if I have the ability to like reach out and with pi, like whatever that is, like actually act in a particular way, and that obeys some regularity about sort of like the way that I hypothesize that I act interfacing with like the belief as being sort of like the central primary object that's like evolving, that has like a very special dynamics of like the beliefs, but like vis-a-vis like the fact that the belief dynamics are like architected in a particular way that I am the one that is poking at it. I guess that's like one impression that I have for that.
Thank you. Shall we?
Yeah, so I've seen the words actions and habits and policy. Is a policy kind of like a habit but with data in it?
Oh, sorry. I think policy is the same as habit.
Oh, okay.
My policy is to 75% of the time always just leave it the same and 20 to heat and 10 to cool or whatever. Yeah, the other way around. Yeah. All right. Okay. We reviewed the setup. We were partway through. We're now in the process of trying to actually create this map by a series of very small primitive functions. We started here, and we got partway. So let's review where we got. So, whoops. Okay. We started with our prior and hypotheses and a habit. We applied our belief updating. We did duoidality and duplicated the action. And then we applied the transition function. And so to remind ourselves where we're at, for each observation, we have a random variable whose outcome is the next state, or the next hypothesis, and the action that got us there. So that's where we're at. Chris?
What's the difference between having a tuple of things and having one above the other? Like, it seems like the outcome is just the action as opposed to the blue. It seems like, anyway, I don't know if there's a difference. It seems like you're able to remember everything along the path.
I think indeed you're like, couldn't you have written these two like a tuple? Yeah. And I'm like, yeah, indeed, like, let's think about polynomials. Hy trie pi is the same as h times pi. The reason I had it here as a tuple was because this is the data you need to apply the transition function, like h times pi, versus this is easier to write, and also I think sort of cleaner here. Okay, so we applied the transition function. That's this thing. Now we're going to apply the likelihood. Oh my goodness. What?
Compose all the lots first.
it's easier to write when we don't. At first I did, and then I was very sad on my little iPad trying to make 16 little things, so we're doing this. I think it's kind of beautiful. Okay, right, so this is the thing we just saw on the last slide. Now we're going to take so this is, remember, for each observation, a random variable whose outcome is the next state, and now we're going to say, if that's the next state, then what do I think my next observation will be? So I'm like replacing this 70 with like, well, it's when it's 70 degrees, 50-50, I feel hot or cold. When it's 85 degrees, 90-10, I feel hot or cold. So what is this? It's for each observation, either hot or cold, a random variable whose outcome is the next observation and the action that got me there. All right, take a picture of that in your mind. You actually didn't need to, because here it is. Okay, so the next thing we're going to do, isn't this a work of art, guys? Okay, so the next thing we're going to do is we're going to add in the preference. So we're going to keep everything exactly the same, like here, exactly the same. And then after, like this is right, for each observation, a random variable whose outcome is the next data, I'm just going to add in my preference. And then 80% of the time I want to feel hot, 20% of the time I want to feel cold. And I'm adding it in so that I can compare them. So I didn't do much. All right, so next, we're going to compare the next observation with the preference. So let's look here. So it's like here, right now I experienced cold. So then I'm expecting with this probability, I'll actually feel hot next time. And that 80% of the time matches my preference for being hot. And so that got me this red line. Those two guys match. And what got me there, it was cooling down the room. That's C at the top. If I feel cold right now, then with this probability, probably I'll feel cold next time. And that, oops, nope, sorry. Oh, it's missing a little line. Okay, probably I'll feel cold next time. And with 80%, that does not match my preference for being hot. So I think that's this red dot. So I'm comparing my next observation with my preference. How are we doing? We're very impressed with all of my hand-drawn trees.
I'm confused about what's the criteria for deleting the things that got replaced with dots. I thought we just have a 80% preference for hot, so we're not eliminating cold, right?
So like let's look at the very end. So we have a dot here and a line here. Let's try to figure out where they came from.
Yeah.
So the dot came from, here is like I expect to experience cold.
Oh, okay.
And that doesn't match my preference for hot. So I put the dot. But it does match my preference here for cold. So I put a line.
Oh, okay.
And what got me there? Cooling the room.
Sure. Okay, thanks.
Nice. Other questions? Sweet. Good news, guys. We're about to do Kevin's favorite thing. We're going to compose the lotteries. Okay, so, I keep saying like this probability, and you're like, okay, Sophie, but what is that probability? Well, we just do 0.17 times 0.2 times 0.75 times 0.5.2, and we get 0.0005. The end. Yeah. And I wrote some very small numbers, which you really care about. Maybe we could find the largest one and see that it makes sense. So this one's very large. Let's see where it comes from. Sorry, this one says 0.2324, and all the other ones start with 0, except for that one. Okay, so let's find out where it came from. So this is, I observed cold, and, oh dear heaven. Okay, so this one is like, this is a lot of memory that I'm doing from remembering how we got all these things. So this is like, I observed cold. That means 83% of the time, the room was actually 70 degrees. Then with 70% probability, I kept the room the same, which means that with 100% probability, the room will stay the same. It'll continue to be 70 degrees. So the next state is 70 degrees. And then with 50% probability, the room, I will feel hot, which 80% matches my preference for being hot, which is that. And so all those numbers multiplied together is that 0.234. And I got there by keeping the room the same. So that's what we did. Whew.
So there's a 23% chance of feeling cold, being right, doing nothing about it, then feeling hot, and therefore being happy.
Yeah. Very simple. I wish I could, yeah. Exactly. Wait, can I try to say it? Okay, you said, given that I saw cold, there's an 83% chance that the room was 70 degrees.
So you were right.
So I was right
That it's cold.
Yeah. And then there's a 70% chance that I don't do anything about it. That definitely works. And then there's a 50% chance that it makes me feel hot, which is 80% what I wanted. Yeah, exactly. All right.
What's the most likely outcome of the situation? That the room is cold, you do nothing, and then you feel hot and you're happy.
Yeah. It's a bit weird because yeah. Well, okay. I bet there's one higher over here. No, there's not. Fascinating. Yeah, I'm somehow surprised that there's not a large one right here.
Do nothing and hot.
Well,
and stay
it's
hot.
possible. Yeah.
Can we look at the inputs again and figure out whether we believe that that's...
Yeah, I'm a little nervous about. In fairness, Claude did all these calculations for me. We can blame Claude. Just kidding. We'll probably blame my input skills. Yeah. Yeah, I'm surprised there's not one that's like, I observed hot. Yeah, I'm happy. Yeah, that seems surprising to me also.
The algorithm of picking the biggest numbers?
Oh, yeah. Okay. 64.7. Oh, yeah, this should be way higher.
Yeah, that should be.
Yeah, okay. So I've just done a wrong calculation.
Yeah, that should be like 0.35 or something.
Yeah. All right, excellent. We have found a mathematical error. We expect this path to, in fact, be the highest. What does that path represent? It represents, I observed feeling hot. I was correct that the room was 85 degrees. I followed my 70% habit of keeping the room the same, which 100% kept the room the same, so the room is still 85 degrees. 90%, that means I feel hot, which 80% I'm happy about. And so that's really the path we expect to be the highest. Pretty fun. Anyone else sad?
In both those scenarios, you didn't do anything, so
It's true, yeah. It makes sense because I have such a high habit about not doing anything that those are going to be the highest weighted paths.
This is a hilarious example for active inference. I have this wonderful policy of usually not intervening on the world, and I feel great.
All right.
And do you have a preference for actions or a preference for states?
Preference for states, for observations. Preference for how I feel. Yeah. We only have one more slide. You guys ready for it? All right. Oh my God, it's even on the same slide. Okay, so now we renormalize. We have all these like dotted out things. Let's get rid of them and renormalize the probability. And so now I get, given that I felt hot or cold, a random variable whose outcome is, do I want to keep the room hot or cold? And I guess as we talked about, like the ones that are, and these ones are only things that like, and the observation matched my preference. And so the big numbers here are going to be like actions, such that given all that stuff, the observation matched the preference. And after I took that action. And so I'm like, yay, that one. Does that make sense? That was a little weird. Or inaction, indeed.
Is there another step where you use
Oh, that's a great question. I want that too. There's not an obvious polynomial map for that.
Yeah, you can't aggregate.
Yeah, but we should ask. We can ask David when he gets back.
Wait, what? That's interesting.
All right.
Is it not natural in poly to renormalize?
No,
Renormalization is fine, but
Or is this aggregation? But in general, if you have,
I think we're asking for
So-
like,
I'm asking this
Oh, yeah.
because we could play with laundry or we could play with weighted sets, and then you wait till the very last moment at any point of time to renormalize if you really want things that sum up to 1, but you can always just play with weighted sets. So my question is it somehow very natural to do renormalization in poly, or is it, you're just doing it because you want to get back to a statistical setting?
so it's very, it's basically like exactly as, it's, what do I want to say? Let's see. It's exactly as natural as like the operation of renormalization itself is. Like when you write down the polynomial map of it, you're like, the renormalization. It has some nice properties in poly. So that's one way it's like, yeah. And so I think you're sort of like, why not just keep this as like y to the d try a weighted
Yeah, so
set,
weighted set.
and then only when you renormalize do you have to add that in.
Yeah.
I don't.
I guess it's stylistic.
Mhm.
But so what is this? Are you going to explain how this has updated my policy?
I can try. Yeah, definitely.
I
How has it updated my policy? Indeed. Okay, so it's like, if I feel hot, then I'm going to flip this sort of coin. And if I get this one, then I'm going to keep the room the same. And if I get this one, then I'm going to cool the room. And that's like my new, that's just like my new policy, or the policy that I'm going to take on my next time. And because these are things that will like give me better chances of getting my preference, or something like that.
I think there's a policy update where instead of starting with a habit, you started with instead of just starting with a habit where you always do nothing for like 70% of the time, you could already have a habit where, depending on the environment, you have some probabilities of actions that you take, and then after this whole process, you again end up with states with probabilities of actions that you take.
That sounded like your question from earlier, like can
Right,
my
so
habit
policies
depend
don't
on
depend
the
on-
hypothesis?
The policies don't depend on your hypothesis, right?
It seems though, I think Xiao was saying that we could soup up this story
Well, I
to
wanted
make that
say,
happen.
like, does it depend on the data?
Does it
rather
depend on
than
the data?
hypothesis?
Right.
Oh yeah, that makes,
And so,
Yeah,
'cause
yeah.
I'm kind of confused actually about the semantics of this, because you're showing like, if I see it's hot, here's how my policy changes. But so then, when you see it's hot, do you use your old policy?
I think I use my new policy.
But wasn't the new policy computed based on what would happen if I responded to
Yeah.
that observation with the old policy?
Yeah. So it's like, okay, I compute, I'm like, suppose I followed my old policy, and I'm like, well, in these cases, it worked out for me, and in these cases, it didn't work out for me. And then I X out the cases where it didn't work out for me. And I'm going to say, like, now I'm only going to consider options where it did work out for me. And that's my new policy.
So why don't you just use, right, so you're saying you're going to actually respond with the new policy, but then
But
you like run the whole update again and get an extra new policy, and that'll be even better or something? The dynamics are unclear.
Because you can combine this with the belief update, and then you get a dynamics on like lot h tensor lot pi, and then so that'll be like lot h tensor lot pi to like yd try y plus 1 try lot h tensor lot pi, and so now you have a dynamics on like the belief and policy like combined.
Yeah.
So that's like, I guess, the impression of what's going on with it.
Yeah. I think, yeah, I like that description. And then also, Kevin, part of me is like, ooh, that's such a great question to now go ask a person who does active inference, who's the expert in active inference. One thing I like about the polynomial story is it makes those types of questions more obvious to me. Whereas like when we're doing them at the board, they feel more murky to me. We're also at time, so I'm going to say thank you. And also, thank you guys for being such an incredible audience.